All right, so today we're going to look at two more transformations, okay, which is amplitude and vertical shifts. So these transformations, I think you'll find the arithmetic easier than yesterday. Like yesterday you had to do common denominators and you worked with pi. You won't have to worry about that today. So the first thing I want to just kind of show you is a diagram. And the amplitude is basically how high or how low the sine wave or cosine wave goes. So from that center line to the peak, that's the amplitude. And the wave is always symmetrical. So however high above the center line you go, that's how low you go below it. Now, earlier I mentioned the idea of recording. Let's say that your maximum volume that the microphone could handle was that line right there. Well, what would happen to this section then when you recorded the sound is that. The computer would basically say, I can't record something that goes that loud. So what I'm basically going to do is I'm just going to clip the signal. I'm going to cut it off, and that's going to sound pretty awful. Okay, you're going to hear like a staticky sound. It's not going to be good. Okay? So controlling amplitude is very important when you're recording something where you've got a sound system that can only handle a certain volume. You got to make sure you turn your input down enough that you don't go over that volume. Okay, so what does an amplitude, change in amplitude look like when you have your equation? Today it's when you multiply by a number in front. So yesterday we added or subtracted a number inside parentheses, right next to the x. Today we're going to multiply by a number in front. Okay, so here's an example of an amplitude change. 3 sine x. So the 3 is going to change the amplitude. Does anybody have a guess how 3 sine x would compare to just sine x? What do you think the 3 will do specifically? Any guess what the 3 would do to the amplitude? Connie, did you have a guess?
We just multiply 3 by sine x.
So what would that look like visually, or what would that sound like to you? What do you think it would sound like if you took a sound that was represented by sine x and then put a 3 in front of that sound?
It would just like jump up.
Jump up? How much louder do you think it would get?
3 times that?
Yeah, it would be, the wave would be 3 times as high and as low as the original. Whether or not that's 3 times louder, that depends on how we hear things in decibels, which we're not going to get into. But what we are going to look at is just the picture. So here's the graph of sine x. Here's the graph of 3 sine x. And you'll see how they compare. So the original graph in blue has a height of 1, goes as low as -1. And the graph in red has been stretched vertically. So it has a height of 3 at the highest, and it goes down to the lowest at -3. Okay, here's another example of an amplitude change. The 2 is going to do something. Okay, it would make the wave twice as tall. Does anybody know what the negative is going to do separate from that? Yeah? Anyone have a guess? Yeah?
Would it invert the wave?
Exactly. It would invert it. It would flip it. So if you had a wave like that, and you flip it, you have a wave like that. Okay? It flips it over. So technically there's 2 things happening in this one. An amplitude change and a flip. Now this is also an amplitude change, but it's a little different. What do you think putting a fraction in front would do? what would it do to the wave? Yep.
Would it shrink it?
Yeah, it would compress the wave. So it'd be like doing something like, I'll just draw it. If that's your original, putting a 1/2 in front might do something like this. Still has a wave to it, but it's been compressed. So we would hear that as a softer sound. Would it necessarily be half as loud? Again, that gets into it. That's a more complicated question. So, if you take the absolute value of the number in front, that's called the amplitude. So, the reason I said absolute value is because amplitude, if you scroll back up, is a height. And height always has to be what kind of number? Positive. Okay, you can't have negative amplitude. So if you get a question like, in fact, I'll put one up in a second. What is the amplitude? Okay, so this is not a graphing problem. All you have to do is write down a number. 2 sine x. What's the amplitude of 2 sine x? Yeah, it's 2. That's the amplitude. What would be the amplitude of negative 2 sine x? Yep,
2.
still 2. Okay, that negative has no effect on the amplitude. It does have an effect on the graph. It's going to cause your graph to flip. But the negative has no effect on the amplitude. Right? So again, when you're graphing, the negative is important. You have to use it. But if all they want to know is amplitude, the negative has no effect. Question on that? What about, let's do the amplitude of 1/2 sine x plus pi. What would be the amplitude of 1/2 sine x plus pi? Yep, Kate.
We shift it to the left a little and
Okay, so what would the amplitude be? It would be 1/2. As Paige just said, that pi is going to shift it left and right. Well, specifically, this one's going to shift to the left. But shifting left has no effect on the amplitude, so you don't even need to look at the plus pi. It has no effect on the problem at all. That's the only thing you need to look at to find the amplitude. And Mason, what if I did this? What's the amplitude now? 1/2. What if I did that? Orion, what would the amplitude be now? It'd still be 1/2. Yep. So, there's basically two different things that can happen with an amplitude change. If the number in front is greater than 1, your graph is going to stretch. Okay, that would correspond to a louder sound. If the number in front, if the absolute value of the number in front is less than 1, that's going to compress your graph. Okay. Notice when I talk about stretching or compressing, I don't even want to think about the negative. The negative has nothing to do with stretching or compressing. That's why I put absolute value. Okay, so examples of numbers that would stretch your graph. 3, 10.7, negative 12. All those numbers I just said are going to cause your graph to stretch. Compress, 1/2, 0.7, negative 2/3. All the numbers I just said would cause your graph to compress. And specifically, we're talking about stretching and compressing on the y-axis. Okay. And we've already talked a little bit about what that would sound like. And it's basically a change in volume. Okay, so I can play that one. Not really as interesting as a phase shift. Okay, but here's so there's a sound. It's 1,000 hertz. That's the frequency. And what I'm going to do is I'm going to lock the left and the right channels together, so that way if I lower the volume, left and right come down at the same time. Okay. And as I start to lower the volume, as I start to compress the wave, eventually it becomes horizontal, and at that point you really don't hear anything. And then it gets louder. Not loud enough to clip. Okay, it's still okay, but it got louder. So any question on affect what an amplitude change sounds like? It's just really a change in volume. All right, so how do we find the 5 key points, or those 5 critical points when you're making a graph? How do we find them? Okay. So amplitude change, we're going to be stretching and compressing on the y-axis. So what values are going to stay the same today? Right?
X.
The x's. It's always great when the x's stay the same, because now you don't need to mess around with the pi over 2, the pi, the 3 pi over 2, the 2 pi. What I just said is going to be the answer to your x values for every single problem we do today. 0, pi over 2, pi, 3 pi over 2, 2 pi. Every single problem in class, every single problem in the homework. That's what you should put in the x column for today. So if the x's are going to stay the same, Matt, what column is going to change?
The y.
The y's. And to find the new y's, it's going to be a very easy operation. Take all the old y values and multiply them by a. Notice I didn't write absolute value of a. If it's a negative number in front, multiply by a negative number. If it's a positive, multiply by a positive. When you're graphing, you have to take into account the negative, because that can cause a flip. The only time you don't is if they ask you for the amplitude, because amplitude is always a positive number. Okay, and the arithmetic is going to be super easy because your y values are all 1s, 0s, and negative 1s. So all you're going to do is multiply a 1, a 0, and a negative 1 by whatever number is in front. Yep.
What is after all? So
All old y values by a. So any question on what's staying the same, and then what's changing and how we change it? Okay, so let's take a look at an example. Okay, so we're going to graph 3 cosine x. Okay, first thing we got to figure out is what kind of transformation is this. Okay, now you know 2. You know phase shift, and you know the amplitude change. Alex, if you could tell me which transformation this one is and then how you know that?
the amplitude.
I agree, it is an amplitude change. And how do you know that?
Because the 3 is right next to the cosine.
Right, you're multiplying by a number in front. Okay. So that's an amplitude change. Okay. So let's make our table. For an amplitude change, how about Cameron? What values stay the same?
The x values.
The x values. Zach, can you remind me what my x values are from the original table? The original x's for cosine.
Oh, it's 1, 0, negative 1, 0, 1.
Those are your y's.
Oh, sorry. 0, pi over 2, pi, 3 pi over 2, and 2 pi.
Yep. Those are also the same x values for sine. Sine and cosine in the original table have the same x's. Okay, now off to the side, I'm going to write my original y values, and then I'll modify them to fit this graph. So how about Haley? Can you remind me what Zach just said? What are my original y values for cosine?
1, 0, negative 0.
Perfect. Okay, and Eric, what am I going to do to all those y values?
Multiply that by 3.
Exactly. I'm going to triple all of them. Write down the answer, and that's it for the table. So Molly, can you multiply all the old y values by 3 and tell me what I get?
3, 0, negative 3, 0.
That's it. There's your table. Any questions on the table? Okay. As always, the table is going to be worth 10 points. 5 points for each. 5 points for the x's, 5 points for the y's. Now let's graph it. Okay. What I'm going to do to graph it is, rather than add more lines, I mean, you could do it this way and put in the 1, the 2, and the 3. I'm just going to have each line on the y-axis go by 3's. So 3, negative 3. My x's are going to be the same. Every problem we do today. Okay, so we're at 3, 0, negative 3, 0, 3. 3, 0, negative 3, 0, back to 3. And there's your graph. Okay, any question on how I got that graph? Okay, a lot of graphs today are going to look very similar. Because let's say instead of 3 cosine x, I made the problem 5 cosine x. Does anybody see 2 things I could change on that graph very quickly, and then I would have that graph? Yeah?
Just change the values on the y to 5.
Yeah. If you just change these 2 values to 5 and negative 5, well, now you've got a graph of 5 cosine x. So if that's how we do it, which that is how we're going to do it, when we have to graph something, we're going to change the scale, then all our graphs are going to pretty much look the same. Okay? So doing it this way is not good for comparing one graph to another, because the graph of 5 cosine x and 3 cosine x, I use the exact same graph. But what I did is I changed my scale. So that's how I'm going to do it. So in your homework, if you're like, geez, a lot of my graphs are looking the same, they're going to, if you change your scale like this. If you use the same scale on every single problem, then your graphs will look different. Okay. But I generally don't do it that way. Okay. Any questions on that? Okay. And Connor, did that stretch the graph, or did that compress the graph? Think about how high and low does the original cosine function go? Yeah, because right, the original cosine function only goes 1 to negative 1. This goes 3 to negative 3. Okay, let's try this one. Take a second on your own and see if you can get the table. Figure out what stays the same, what's going to change. And then once you know what's going to change, figure out how you have to change it using the number in the problem. All right, so first thing, this is an amplitude change. Is this going to stretch the wave or is it going to compress it?
Compress.
Yeah, it's going to compress. How do you know?
It gets smaller.
How do you know it's going to get smaller?
It's by half.
By its half, right? It's a number that's a fraction, less than 1. It's a half. Okay, so amplitude change, y values stay the same. Irene, can you tell me my y values for sine? Oh, actually, you know what? Those are the ones that are going to change. Tell me my x values. I messed up. X values are going to stay the same.
0, pi over 2,
Yep.
pi, 3 pi over 2, over 2 pi.
2 pi. Okay, so you should have those x values for that problem and every problem we do today. Y values are all going to be multiplied by a half. You don't have to write the originals. If you can do it in your head, just multiply by a half, that's fine. So you have 0, half, 0, negative a half, back to 0. Okay. Did anybody get all the y values correct? Anybody got those? Yep. Okay, so let's look at the graph. Okay, on the graph, this is going to look the same as every other sine graph because I'm going to scale it. I'm going to make the top line a half. I'm going to make the bottom line negative a half. If you don't want to do it that way, you don't have to. You could draw another line in here and say that's going to be 1, and that's going to be a half. Right? However you want to do it, as long as I can understand what you're doing. Okay. What you do have to do, though, is label your x's. Okay? On a graph, if you forget to put your labels, I'm going to assume you're going to go by ones. Because that's what a graph always goes by if you don't label it. So we're at 0, 1, 0, negative 1, back to 0. How about Faith? What's the amplitude of that graph? Exactly, 1/2. Any questions on that? Let's try one more. Okay, negative cosine x. What's the amplitude on that graph? Right?
1.
1. So technically this isn't an amplitude change, but we are multiplying by a number in front. That's why it falls into the category. What number is really in front even though we don't see it? Yeah, or in this case a negative 1. So the height isn't going to change, but what did we say the negative is going to do? It's going to flip it. So everything that was positive for the y's is going to become negative and vice versa. So copy down your x's. Okay, and my original y's would have been 1, 0, negative 1, 0, 1. And we're going to multiply them all by negative 1. So just change the sign. Negative 1, 0, 1, 0, negative 1. So amplitude change and the last transformation I'm going to show you today, the arithmetic is super, super easy. Okay. Any questions on the table? Okay, let's set up our graph. Technically, I don't have to label 1 and negative 1 because I said if you don't label anything, I'm going to assume you're going by ones. But I like to label it. All right, and we're at negative 1, 0, 1, 0, negative 1. Negative 1, 0, 1. Back down to 0. And negative 1. So what this has done is it's flipped that wave, okay, the part that we're going to sketch. And remember, it's a wave. It would keep going. But we're only sketching one small section of it. Does anybody remember what you call this? One section is called a...
Period?
Yep, it's a period. It's also called a cycle. One cycle of the graph. Great. Any questions on that one? Okay, so that's amplitude change. And the last one we're going to do a couple examples of is a vertical shift. Now, a vertical shift looks something like that. You add or subtract a number on the end. So there's an example. Sine of x plus 2. Cosine of x minus 3. One of these is going to shift up, one of them is going to shift down. But how come that's not a phase shift? I thought phase shift was when we did addition or subtraction. What's the difference between the addition and subtraction I'm doing here and the one I did yesterday? Ready? Yeah, it's not grouped with the x. A phase shift has to have a number added or subtracted with the x, grouped in parentheses. Okay, so if I do something like that, that's still a vertical shift. If I did something like that, that's a phase shift. Now I change the problem. Okay, anyone have a guess which one is going to move up? You think the sine one or the cosine one? The cosine one? So you're thinking like the phase shift, like the opposite idea we did yesterday? Anyone think the sine one? Yeah, it is the sine one today. So if you graph, I'll just graph sine of x, and then sine of x, close the parenthesis, plus 2. There's your original. And here's the new one. So it's the same graph, just shifted up 2 units. So vertical shift is one of the transformations where you don't do the opposite. Okay, somehow you have to remember that for the test. If you want to put it on a reference sheet or however you do it. Okay. Vertical shift, don't do the opposite. Okay, so vertical shift will move your graph up. If you add, it'll move it down if you subtract. Don't do opposite. Don't. If you do the opposite, you get it wrong. Okay, so don't do the opposite. So in terms of which values are being affected, if you shift something up and down, okay, what values are going to change? If you shift up or you shift down? Yeah, the y's. So in terms of the table, it's pretty much the same thing we did last time. Your x's are going to stay the same, but now it's your y's that are going to change, but we're not going to change it exactly like we did before. We're not going to multiply by a number. That was amplitude change. So x's stay the same. So you could just write x's stay the same. If you don't know what else that means, then you should put the next sentence which says, so in the new table, copy down your x's from the original table. If you already know that, you don't need to write it. So to find the new y values, all you have to do is look at what you've added or subtracted. Okay, I called it D. Call it whatever you want, but I called it D. And do that to all the y values. Okay, if you did a plus 2 on the end, do a plus 2 to all the y values. If you did a minus 5 on the end of the function, you're going to do a minus 5 to all your y values. Okay, so again, arithmetic is super easy because all you're going to do is add or subtract a number to a 1, a 0, or a negative 1. That's it. Okay, so we'll try 2 examples of that. We'll do one where we shift up, we'll do one where we shift down, and that'll be it. Okay, any questions on the 2 steps? So this is the one I think I just did on the graphing calculator. Sine of x plus 2. Robin, what column is going to stay the same?
X's.
Yep, x's. And Connor, can you remind me, what are my original x's?
0, pi over 2, pi, 3 pi over 2, 2 pi.
Okay. So those are my original x's. Emily, can you tell me what my original y values are for sine before we do anything to them?
For sine.
Yeah, for sine.
0, 1, 0, angle 0.
Yep. So we got 0, 1, 0, negative 1, 0. How about Ryan? What am I going to do now to all those y values?
2.
Yeah, I'm just going to add 2. So Mason, can you tell me what I get when I do out all those calculations?
2, 3, 2, 1, 2.
2. Perfect. 2, 3, 2, 1, 2. That's it. That's a shift up. Now we graph it. This time I need to go as high as 3 and as low as 1. So I would just set up your axis like that. X-axis, same way we've been doing it. Now graph your points. 2, 3, 2, 1, 2. So 2, 3, 2, 1, 2. And there's your graph. As far as a connection with sound, I don't really know of one. This program I have here, you can't shift the sound wave up and down. You can stretch it up and down, you can stretch it left and right. You can shift left and right, but I can't shift up and down. So I'm not aware of any effect on the sound with that. Okay. Alex, what's the amplitude here? Exactly. Amplitude is 1. What if I asked you, what's the maximum height? What's the highest number that it ever hits?
3.
Perfect. Okay. Amplitude, if you imagine that center line, that's how high and low it goes off the center line. It's still 1 in this case. But the maximum number it hits is a 3. Good. Okay. That's the last one. Cosine of x minus 5. Now I added some parentheses in there. Do those parentheses make it a phase shift? No? Ryan, how come? I thought when I put parentheses it was a phase shift.
No, it's only when the number is inside the parentheses.
Like that?
Or with the x.
With the x. So the key is you have to have the number and the x in parentheses together. So that is still a vertical shift. So Matt, what's going to stay the same here?
The x's.
X's. And hopefully by now, I'm starting to kind of remember what those are. My y's. How about Ileana? Can you tell me my original y values for cosine?
1, 0, negative 1, 0.
Perfect. And how about Zach? Can you tell me my new y values after I subtract 5 from all of them?
Negative 4, negative 6, negative 5, negative 4.
Perfect. And there's your y values. Does anyone need me to do the graph for that one? set up your x-axis just like always. For your y-axis, I would just label it -1, -2, -3, -4, -5, -6. So I would just kind of set it up like that. Okay, so those are the second and third transformations we're looking at. So we've done the phase shift, we've done amplitude change, and now we've also done the vertical shift. The last transformation we'll do tomorrow, and that has to do with stretching and compressing horizontally, which changes frequency. So then we can start to get into some really interesting kinds of stuff. Okay. So homework tonight, it will be a worksheet. Again, I think it's 5 questions, just like last night. I'll make sure it's in the video, so if you lose it, you can at least look the problems up on